Hi, what's up, kids? Hope you're all doing good. I miss you so much. Did you get the news? This will be our last science video recording. Cool, isn't it? In this video, we will make a revision about the three last lessons of Chapter 9. In these lessons, we defined matter, we talked about different properties of matter, and we talked also about different types of mixtures. So, let's start now. What's matter?
Hey, what's matter? No, not what's the matter. Obviously, since you're here with me, you're pretty awesome at the moment. You might have heard that everything is made of matter, and that's true. You, soccer balls, iPads, even your pet Fluffy, all made of matter. So that's interesting. But what is matter exactly? The scientific answer is matter is anything that has weight and takes up space.
People describe objects by identifying their properties, such as size, shape, colors, and textures. A property guide describes how an object looks, feels, or acts. Objects that take up space and have mass are called matter. That's right. Everything, and I mean everything around you, is made up of matter. A chocolate cake is made up of matter. French fries are made up of matter. This phone is made up of matter. You are made up of matter. Matter also makes up the walls of your house and your classroom. So anything you see and can feel is made of matter. That's right. And objects that are made of the same kind of matter, like the jar in here and the bulb, share similar properties. Didn't we say that everything is made of matter? Take a look on this picture. What do you think? What are different kinds of matter that you can identify? Let's start with the ball that the girl is holding. This ball is made up of rubber, isn't it? The rubber that makes up the ball is made of matter. What's inside the ball? Yes, that's right. The ball is filled with air. The air that fills up this ball is made of matter. That's right. Okay. In the other hand, the girl is holding a glass jar. The glass jar is made of matter. That's right. She's drinking some lemonade. We have now the lemonade in a plastic cup. The plastic is a kind of matter. Yes. What about the lemonade itself? Water and lemon juice used to make lemonade are made of matter. So again, anything that you can see and that you can feel is made of matter. Can you check these three different objects? We have scissors, magnifier, and a knife. What are the scissors made of? Plastic, perfect, and metal, steel. So, these scissors are made of two kinds of matter. What about the magnifier? Also, two different kinds of matter, glass and plastic. Take a look on the knife. The knife is also made of two different kinds of matter, leather and metal, which is the steel. So, some objects are made of more than one kind of matter. As you can see, scissors are made of two types of matter, plastic and steel. The magnifier is also made of two types of matter, glass and plastic. The knife is made of leather and steel, two kinds of matter. So, an object can be made of one or more kinds of matter.
We're gonna talk about another property of matter called mass. But not this kind of mass I'm talking about. The mass I'm referring to is the amount of matter that an object or a body has. Imagine a bottle with 2 drops of water. It's almost empty, right? But if I pour water to the top, I greatly increase the amount of water. Which means more matter, more mass. So we can say the more mass an object has, the more difficult it will be to move it. For example, moving this pencil requires few strength because it's light and small. This pencil should have only 10 grams. But if I move my entire workbench, it will be a lot harder because it has much more mass. Whew, must have more than 100,000 grams or 100 kilograms. So, kilograms and grams are some of the ways we measure mass.
Objects have mass. Mass is the amount of matter in an object. The unit for mass is a gram. So the mass of an object depends on the quantity of matter that this object contains. Let's take a look on this block and the feather. What object contains more matter in it? It's the cinder block, that's right. So which object has more mass than the other? Perfect! The cinder block has more mass than the feather. What about the table and the ruler? Both are made of the same kind of matter. They are both made of wood. The table is made of wood and the ruler is also made of wood. But do they have the same mass? No, perfect. The table has more wood in it, so it has more mass. Perfect. A table has more mass than the ruler. Can you help me solve this question? I use a pan balance to measure the mass of a ball. And as we know, a pan balance is a scale which has 2 pans that are balanced against each other. So I placed a ball on one pan and the 20 grams weight on the second pan. Take a look on the pan balance. Are the 2 pans balanced? Are they on the same level? No, that's right. Which object is heavier? Is it the ball or the 20 grams weight? It's the ball, that's right. So does this mean that the ball measures exactly 20 grams? No, good job. So is it more than 20 grams or less than 20 grams? It's more than 20 grams. Perfect. So the mass of the ball is more than 20 grams since the pan containing the ball dropped while the one containing the 20 grams weight raised. So the 2 pans are in balance. This means that the 2 objects do not have the same mass. Okay? Thank you. You did it.
Matter also has volume. You better turn it up. I don't hear anything. No, not that kind of volume. When it comes to matter, volume means the amount of space something takes up.
The amount of space?
Yeah, how big it is. Before I made the elephant models, I made a mouse for practice. It takes up a lot less space than the elephant, so it has less volume.
Yeah, but these 3 elephants are all the same size. They take up the same amount of space, so their volume is the same.
Sure is.
All objects take up space. Your computer is taking up space on the desk. You are taking up space on the chair. Let's take a look on these 2 balls. We have 2 balls with different sizes, ball A and ball B. Which ball takes up more space? Which one is bigger? It's ball B. Good job. So ball B is taking more space than ball A. Which one has more volume? It's again ball B. Perfect. Ball B is taking up more space. What means that ball B has more volume Since volume is the amount of space that an object takes up, right? What about the volume of the liquids in these graduated cylinders? We have 4 graduated cylinders in which we have liquids with different volumes. As I said before, you have to be careful and to identify the scale used before start reading the volume of the liquid. Let's take a look on the first one. Each 10 lines are equal to 10 milliliters. This means that each line is equal to 1 milliliter. So let's start counting. 10, 11, 12, 13, 14. The volume of the liquid in the first graduated cylinder is equal to 14 milliliters. Let's move to the second one. Each 10 milliliters or each 10 lines are equal to 10 milliliters. So they use the same scale. Each line is equal to 1 milliliter. Let's start counting from here. 40, 41, 42. Perfect. So the volume of the liquid in the second graduated cylinder is 42 milliliter. Perfect. Did they use the same scale on in the third graduated cylinder? Let's see. Each 5 lines are equal to 25 milliliters. What do you think? Each line is equal to 5 milliliters. Good job. Let's check. 5, 10, 15, 20, 25. So each line is equal to 5 milliliters. We'll start counting from here. 75, 80, 85, 90. So the volume of the liquid in the third graduated cylinder is 90 milliliters. Perfect. Good job. Let's move to the last one, last graduated cylinder. As you can see, each 10 lines are equal to 100 milliliters. What does this mean? Each line is equal to 10 milliliters. That's right. So let's check. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So each line is equal to 10 milliliters. Let's start now counting from here. 200, 210, 220, 230, 240, 250 milliliters. So the volume of the liquid in the last graduated cylinder is 250 milliliters. So each time we want to read the volume of a liquid in a graduated cylinder, we have to find the scale used. Let's recap. What's matter? Matter is everything around us. And all matter have properties. They have a mass and they also have a volume. But what's mass? The mass of an object is the amount of matter that this object contains. And what's volume again? It's the amount of space that an object takes. Yes. But what happens if we mix different kinds of matter together? Take 3 different cups and in each one of these cups put some water. In the first one, add 1 spoon of sugar and mix them. In the second one, add some sand. And in the third one, add some salt. We have now 2 different types of mixtures. In the first cup and in the third cup, the salt and sugar disappear. We cannot see them anymore, and the mixture now is made of one color, one phase. In the second cup, sand didn't dissolve in water. The sand particles settled to the bottom of the jar. But in these three cups, we have mixtures. Mixtures is a substance that is made up of two or more kinds of matter, and we have two types of mixtures. The one with one color or phase, which is called homogeneous mixture, and the one like the sand and water mixture is made of two phases, the phase of the sand, the phase of the water, two different phases. Sometimes it contains more than two phases, and these kinds of mixtures are called heterogeneous mixtures.
What are some examples of homogeneous mixtures and heterogeneous mixtures? Answer. Homogeneous mixtures are mixtures in which the constituents don't appear separately. 1. Blood. 2. A sugar solution when the sugar is completely dissolved. 3. A mixture of alcohol and water. 4. A glass of orange juice. 5. Salty water where the salt is completely dissolved. 6. Brewed tea or coffee. 7. Soapy water. 8. A diluted solution of hydrochloric acid. 9. Hard alcohol. 10. Wine. In heterogeneous mixtures, the constituents appear separately. 1. Oil and water. 2. A soil sample. 3. Sandy water. 4. A carbonated beverage or beer. The CO2 gas appears separately within the liquid. 5. Orange juice with pulp in it. 6. Water with ice cubes in it. 7. Chicken noodle soup.
I dropped a coin in a cup of water and I tried to make it disappear. Okay? Look what I got. I got a cup of water with a coin in it. What do you think? Is this mixture a homogeneous or a heterogeneous mixture? How can we know? We have to count the phases or the colors. How many phases does this mixture contain? 2. Perfect. We have the phase of the coin and the phase of water, two colors, the colors of the coin and the color of the water. So 2 phases. This means that this is a heterogeneous mixture. Perfect. So this mixture is a heterogeneous mixture since it shows 2 phases. What about this question? How can you separate a mixture of salt and sand using the following materials? A rock salt is a mixture of salt and sand. And what we have to do is to separate the salt from the sand. What is the first step to do? Yes, good job. We will put the rock salt in water. We will stir the rock salt in water so the salt will dissolve in it. Then we will have a mixture of water, salt, and sand. Does sand dissolve in water? No. So how can we separate sand from the salty water? What can we use? Yes, we will use the paper filter. The filter paper will hold the sand in it and will let the salty water pass through it. So in here, we will have water and salt. Now, how can we separate the salt from water? What can we do? Perfect, by evaporation. We will leave the salt solution in a sunny place, or we can heat the mixture. The water will evaporate, leaving the salt behind. This way, we separated the sand from the salt. Thank you.
Mixtures and solutions. Now, a mixture is anything made by combining 2 or more different substances. For example, if you've ever eaten a fruit salad, you've seen a mixture. You make a fruit salad by mixing together blueberries, raspberries, kiwis, grapes, and any other fruits you'd like. Now, a key feature of a mixture is that the substances do not react with each other. For example, in your fruit salad, nothing has changed about the fruit just because you've mixed it together. If you wanted to, you could separate out each individual fruit and see that nothing about it has changed. Now there's one more type of mixture. It's called a solution. A solution is a mixture where substances are spread out evenly. The best example of this is to think about putting a spoonful of salt into water. If you put the salt into the water and stir, the salt dissolves, making it look like it isn't there anymore. But what's actually happening when you dissolve salt in water is that the particles of salt are spreading out evenly among the water. You just can't see them anymore. In solutions, the substance that's dissolving, which here was the salt, is called the solute. And the substance that things are dissolving in, which in our example was the water, is called the solvent. An easy way to compare mixtures and solutions is to think about taking a spoonful of each. If you were to take a spoonful of fruit salad, one time you might get a spoonful of blueberries, and the next time you might get a spoonful of raspberries. Each time you take a spoonful, it would be a little bit different. But in a solution like salt water, every spoonful you would take would be just as salty. There will be no extra salty spoonfuls because it's all mixed evenly together. Now let's practice identifying mixtures and solutions together. Let's start by deciding if this bowl of Cheerios represents a mixture, solution, or neither. Well, what is the definition of a mixture? Remember that a mixture is anything made by combining two or more different substances. And in our bowl of Cheerios, assuming there is no milk, do we have two different substances? No, all that's in this bowl are Cheerios, so this is neither a mixture nor a solution. Now let's look at another bowl of cereal. Imagine pouring yourself a bowl of Raisin Bran. Well, what is being mixed together in a bowl of Raisin Bran? Well, Raisin Bran is made by mixing together both raisins and cereal. So what is Raisin Bran? Raisin Bran is a mixture, but not a solution. It's a mixture because it's made of two different substances, but it's not a solution because it's not evenly mixed together. If you were to eat a spoonful of Raisin Bran, sometimes you get more raisins, while sometimes you get more cereal. Because it's not evenly mixed, we cannot call it a solution. On the other hand, this is an example of a solution. When I take this flavor and I squirt it into a cup of water, it makes a solution. Why is this called a solution? This is called a solution because the water and the flavoring are evenly mixed together. Every sip you would take from this cup would taste exactly the same, because the flavor and the water have spread out evenly. Now it's time for you to practice on your own. Here is a bowl of trail mix. What does this represent? This bowl represents a mixture. Two or more things are being mixed together, but they are not evenly mixed. If you were to grab a handful, sometimes you'd end up with a bunch of M&Ms, while other time you might end up with a bunch of nuts or raisins. So this is a mixture, but not a solution. Next, here's a spoonful of sugar being added to a cup of tea. What does this represent? Well, this would represent a solution, because the sugar and tea will become evenly mixed together. Every sip will be just as sweet as any other sip.
Solutes plus solvents make solutions. A solution is a mixture in which the particles of the mixed substances are so small that you can't see them, even under a microscope. The most familiar examples of solutions are solids dissolved in liquids. The two components are given special names. The substance that dissolves is called the solute, and the substance it dissolves into is called the solvent. For example, when you dissolve sugar in water, sugar is the solute and water is the solvent. We can also say that sugar is soluble in water because it dissolves easily. But sugar is insoluble in other liquids, such as oil. Water is a good solvent because it can dissolve a large variety of substances. We depend on this fact to stay alive. For example, one of the ways we digest food is by dissolving the water-soluble parts of it, such as salt and sugar in saliva, which is over 98% water. The plasma in blood is a water-based solution too. It carries solutes such as salt, sugar, and proteins around the body to where they're needed. As well as solids, some gases dissolve in water, and this is important for life as well. Fish stay alive by using their gills to extract oxygen dissolved in seawater. Shellfish, crabs, and prawns use dissolved carbon dioxide and salt to build their shells. Solutes plus solvents make solutions, a type of mixture we cannot do without.
Sugar water is a solution because it contains sugar particles that are dissolved in it and we cannot see them. What are the two parts of a sugar solution? First, we have the sugar particles that are dissolved in water. The substance that dissolves in another substance is called a solute. Okay? And we have on the other hand, the water, which is the substance that made the sugar particles dissolve. We call this substance the solvent. So the solvent is the part in which the solute is dissolved. So again, a solution is made of two parts. We have the solute and we have the solvent. The solute dissolves in the solvent. So solute plus solvent give us a solution. In these three solutions, the solvent is the same. The solvent is water. That's right. So to make coffee, to make tea, to make water and vinegar, to make a soft drink, you will need water as a solvent to make other substance dissolve. But what had dissolved in the first cup, in the cup of coffee? What did you dissolve in water? Instant coffee, that's right. So we put some coffee in water and we made it disappear. So the instant coffee, which is a solid, disappeared or dissolved in water. Okay? In the second case, we mixed some water with vinegar. So the vinegar had dissolved in the solvent. The vinegar is a solute that had dissolved in the solvent, which is the water. Vinegar is liquid. Okay? And in the third case, we put some sugar. We added sugar to the water. We added gas particles to the water. So we add something that is gas to the water and we made it dissolve. So a solute can be a solid, a liquid, or a gas. Okay? When the solvent is water, the solution is called an aqueous solution. Okay? Water can dissolve solids, liquids, and gases. An aqueous solution is one in which the solvent is water. So we do not care for the solute. We look at the solvent. When the solvent is water, we call the solution an aqueous solution. Okay? Help me now classify the following mixtures into heterogeneous mixtures and homogeneous mixtures. If the mixture is a heterogeneous mixture, we will cross it together. Deal? Let's take a look on the first mixture. We have a fruit salad. How many colors does this fruit salad show? We have something that is purple, orange, red, yellow, green. So this mixture shows many colors. So more than one face. What do you think? Is it a homo or heterogeneous mixture? Hetero, perfect. So what we have to do? Cross it. Good job. B, we're mixing some ink. Let me write here ink and water. The ink will dissolve in water. So what will we get? Will we get a homo or a heterogeneous mixture? Homogeneous mixture. Perfect. So let me circle it. Ink plus water will make a solution, a homogeneous mixture. We should not cross it. C, we have a mixture of nuts. Do you see one phase or more than one phase? Well done, more than one color, more than one phase. So is it a homo or a heterogeneous mixture? Heterogeneous mixture, let's cross it together. Fourth mixture, we are putting some water with ice cube. We will wait a bit. What will happen to the ice cube in water? They will melt, that's right. Will you still see the ice cubes in water? No, good job. So what will we get? A homo or a heterogeneous mixture? A homogeneous, perfect. So I will circle it. This will give homogeneous mixture. Fifth solution now. We have some oil with water. Do you see a mixture with one phase, one color, or more than one color? More than one color, that's right. We have two colors. One, the color of oil. Two, the color of the water, right? So what is this? What is this? Is it a homogeneous or a heterogeneous mixture? Heterogeneous mixture. Let's cross it. Last mixture now. We have milk with ice cube. We will wait a bit. What will happen to the ice cubes in milk? They will melt. That's right. Will you still see the ice cube in milk? No. So we will have one color, white color, the color of the milk. Okay? So homo or heterogeneous mixture? Homogeneous. Perfect. Let me circle this. Seawater is also a homogeneous mixture. It tastes salty because it contains salt, but we cannot see the salt particles. Seawater is a solution because it contains salt particles that are dissolved in water, right? We cannot see these salt particles. But can we take salt from seawater? Yes, this happens in salterns. A solvent is a set of pools in which we leave seawater. The water evaporates, leaving the salt behind, and this salt is used, okay, by people. But can we do the opposite? Can we get drinkable water from the seawater? Yes, we can. What do we call this process? Desalination, that's right. So, in salterns, we leave seawater until the water evaporates and the salt is left and will be used. But in the desalination plants, we remove salt from the water so we can get drinkable water, a water that we can drink. And we're done. I know that you know almost everything that I talked about in this video, but if you still have anything to ask about, any clarification, I'm always here to answer all of your questions. I love you and thank you for watching. Bye bye.